Okay, this is sample problem 1612. The Ka, the ionization constant for hypochlorous acid, HClO, is 3.5 times 10 to the negative 8. Calculate the pH of a solution at 25 degrees Celsius. That is 0.0075 molar in HClO, hypochlorous acid. Okay, so hypochlorous acid, the fact that it has a Ka indicates that it's a weak acid. So we're going to treat this as a weak acid problem. So step one, you write the chemical formula for the acid. So HClO. Okay, so that's hydrogen, chlorine, oxygen. We react it with water. It's a weak acid because it has a Ka, and the Ka is less than 1. Donate an H plus to the water. So the water now becomes hydronium. This is the conjugate acid. And then you're left with ClO minus, that's the conjugate base, right? Bronsted acid-base chemistry. You transfer the H plus from one reagent to the other, one reactant to the other. Then we set up our ice table. The initial concentration of the acid is 0.0075. So I'm going to go ahead and write that in scientific notation. So there's our initial concentration. This needs to be in molarity units. If they gave you the moles and then they gave you the volume in liters, you would take the moles and divide it by the liters so that you have it in molarity. Water is a liquid. Liquids are not included in ice tables. These are initially 0. Q would be 0, so that means the reaction goes toward the products, so you get minus X plus X plus X. Equilibrium, 7.5 times 10 to the minus 3 minus X, 0 plus X, 0 plus X. So Ka is given as 3.5 times 10 to the minus 8. That's a really small Ka. That would be equal to the products, X times X, divided by the reactants. Let's go ahead and make the assumption that X is going to be really small compared to 7.5 times 10 to the minus 3. Okay. So now we can solve for X. Multiply both sides by 7.5 times 10 to the minus 3, and that will give us X squared. Right? We're taking the value of the Ka here, multiplying it by 7.5 times 10 to the minus 3. Okay, so 3.5 times 10 to the minus 8 times 7.5 times 10 to the minus 3. Let's do it this way. 3.5 times 7.5. That's 26.25. And then 10 to the minus 8 times 10 to the minus 3, just add the exponents. Negative 8 and negative 3 is negative 11. Now notice that's not in scientific notation. It's not a number between 1 and 9 times 10 to the x, but we're solving. This is just an intermediate step. So this doesn't have to be in scientific notation. So that's x squared. So let's just take the square root of both sides. X would be the square root of 26.25 times 10 to the minus 11. Okay, so 26.25 times 10 to the minus 11. Okay, take the square root. 1.62 times 10 to the minus 5. There's your x. Keep in mind, X is hydronium concentration. So pH is negative log of X. Still have that number in memory, right? So we'll take the log, base 10, multiply it by minus 1, 4.79. There you go. Now let's go back. It doesn't ask us to do this, but let's go back and do the test. That sort of 5% test, which is a way of determining whether our assumption that this difference is equal to this number here. So what we do is we take X, and we figured out X is 1.62 times 10 to the minus 5. Excuse me. Divide that by 7.5 times 10 to the minus 3. Now, this would be equal to 1.62 times 10 to the minus 3. .62 over 7.5. That's definitely less than 5. So it's good assumption.